In 7 years, on December 22, 2032, an asteroid named 2024Y may collide with Earth. It has a diameter of about 40 to 100 meters, comparable in size to a Boeing 737, the Statue of Liberty, or Big Ben. It may not seem very large, but if it hits Earth, we can refer to the Tunguska event. In 1908, an asteroid approximately 50 meters in diameter destroyed 2,000 square kilometers of Siberian forest and caused at least 3 deaths. This was just a strike in a sparsely populated area. If it hit a city, the consequences would be unimaginable. Besides 2024Y24, on April 13, 2029, another asteroid named Apophis will pass close to Earth. This asteroid has a diameter of over 450 meters. If it were to collide with Earth, the destruction would be far more severe than the loss of 2,000 square kilometers of forest. It would cause global disasters, releasing energy equivalent to 1 million times that of the Hiroshima atomic bomb, enough to destroy any major city. The shockwave from the impact would trigger powerful earthquakes and tsunamis, with waves reaching hundreds of meters in height, swallowing all coastal cities. Additionally, consider this news from last year. NASA's simulation revealed that on July 12, 2038, an asteroid has a 70% probability of hitting Earth, and we currently may not have countermeasures. Some even say this could lead to human extinction, suggesting that moving to Mars might be the only hope for survival. So, how credible are such news reports? Which asteroids pose real threats to humans? Is humanity truly defenseless against asteroid impacts? In this video, I will address these 3 questions. First, let's clarify the differences between asteroids, comets, and meteoroids. Asteroids generally refer to rocky bodies orbiting the Sun in the solar system. While they orbit the Sun like planets, they are much smaller in size and mass, ranging from just a few meters to 1,000 kilometers in diameter. The smallest known asteroid is only 2 meters wide, while the largest, Ceres, is about 940 kilometers in diameter. Approximately 90% of known asteroids in the solar system are located in the asteroid belt between Mars and Jupiter, with millions of them estimated to exist. Although this sounds like a large number and illustrations often depict them as dense, the average distance between any 2 asteroids in the asteroid belt exceeds 1 million kilometers, making the actual space extremely sparse. The probability of a spacecraft colliding with an asteroid while passing through the belt is nearly 0. However, these asteroids can sometimes leave the asteroid belt and approach Earth. Such asteroids are called near-Earth asteroids (NEAs). Theoretically, all NEAs have the potential to collide with Earth. NEAs are just one type of near-Earth object, NEOs, which also include comets and meteoroids. In terms of composition, asteroids are primarily made of metal and rock, while comets are a mixture of ice and rock. In terms of location, asteroids inhabit the asteroid belt between Mars and Jupiter, while comets originate from the Kuiper belt and the Oort cloud. The Kuiper belt, a dense ring-shaped region beyond Neptune's orbit, lies about 40 to 50 astronomical units from the Sun and consists of small celestial bodies and solar system remnants, serving as the source of short-period comets. Pluto is also a Kuiper belt object. The Oort cloud, beyond the Kuiper belt, is not a planar structure like the solar system, but a spherical shell encasing it. With its inner edge about 2,000 to 5,000 astronomical units from the Sun and its outer edge at 100,000 astronomical units, 1.5 light-years, considered the true boundary of the solar system. Long-period comets originate here, with orbital periods exceeding 200 years. It's hard to fathom how vast this distance is. Take Voyager 1, for example. At its current speed of about 1.6 million kilometers per day, it would take about 300 years to reach the Oort cloud and approximately 30,000 years to exit its outer edge. In appearance, comets have a long tail when moving, which asteroids lack. In size, comets are generally larger than asteroids. They can often be seen with the naked eye when passing near Earth, while asteroids usually require a telescope. However, comets may pose a greater threat to Earth than asteroids. First, most comets threatening Earth originate from the Oort cloud, with much more distant orbits and thus much higher speeds than asteroids. An asteroid's impact speed is about 17 kilometers per second, while a comet's speed is 3 times faster, around 51 kilometers per second. Thus, comets deliver much greater impact force at the same mass. Second, Comets are harder to detect and could potentially appear near Earth unexpectedly, with no advance warnings to global space agencies. Currently, we can only detect them 2 to 5 months in advance. For example, in 2013, scientists attempted to predict whether comet sighting spring originating from the Oort cloud would hit Earth based on observational data but found it impossible. In most cases, such comets can only be confirmed as potential impactors about a month before a possible collision. However, most near-Earth asteroids now can be detected years in advance. In addition to comets and asteroids, there are meteoroids, essentially fragments broken off from asteroids or comets, typically under 1 meter in diameter. When meteoroids enter Earth's atmosphere, friction with air generates high heat, causing them to glow and form meteors. Many people have seen meteors, and when this occurs on a large scale, it creates meteor showers. If a meteoroid completely burns up in the atmosphere, no residue remains. If not, the remaining fragments fall to the ground as meteorites. Earth experiences several meteorite impacts each year, though none are of large scale. Now, let's revisit the 3 news stories mentioned earlier. Media reports have made it sound as though humanity will go extinct in just a few years, but in reality, none of these 3 stories should be believed. First, the third story claims a 70% probability of an asteroid impact on July 12, 2038. This is actually false. The scenario was a hypothetical posed by NASA to explore whether humanity could prevent such an impact, with experts from global space agencies like NASA and ESA participating in discussions. Unfortunately, many media outlets misrepresented this as factual news by twisting the context. Next, consider the asteroid Apophis. Discovered in 2004, it astonished scientists due to its rare proximity to Earth. For an object of its size, such events occur on average every 800 years. Coupled with an initial impact probability of 2.7% for April 13, 2029. This low but non-zero risk of an extinction-level event inspired its name. Apophis, the ancient Egyptian god of darkness and chaos, depicted as a serpent that could plunge the world into eternal darkness. However, subsequent observations reduced its 2029 impact probability to 0, and NASA has ruled out any chance of it hitting Earth within the next 100 years, removing it from the list of hazardous near-Earth objects. As seen in the risk list published by the European Space Agency, sorted by threat level, including diameter, predicted collision date, and probability. The current top-ranked object is the newly discovered asteroid 2020 for VR for 2020 for denotes the discovery year. VR for indicates it was the 4th asteroid found in the second half of 2024, with a diameter of 40 to 100 meters. It has a 1/645th approximately equals 0.15% probability of impacting Earth at 2:03 p.m. on December 22, 2030 based on the latest official data from February 21st. With second on the list is asteroid 2023 VD3, discovered in 2023, 11 to 24 meters in diameter, with a 1/387th approximately equals 0.26% impact probability at 5:09 p.m. on November 8, 2034. Despite its smaller size, its risk should not be underestimated. A similar event occurred on February 15, 2013. When an 18-meter asteroid entered Earth's atmosphere over Chelyabinsk, Russia, at 19 kilometers per second and exploded 22 kilometers above the ground. Brighter than the sun, the blast released energy equivalent to 30 Hiroshima atomic bombs, injuring 1,491 people and damaging over 7,200 buildings, making it the largest known natural object to enter Earth's atmosphere since the 1908 Tunguska event, though miraculously caught. Third is asteroid 1979 XB, a massive 400 to 900 meter object with a minuscule 1/1,270,000 approximately equals 0.0002% impact probability at 9:38 p.m. on December 12, 2056. Odds so low that they are nearly negligible. As shown, humanity has a clear understanding of which asteroids pose significant threats. How are these asteroids detected? For primary observation programs lead this effort. 1. Lincoln Near-Earth Asteroid Research Linear, a collaboration between the U.S. Air Force, NASA, and MIT's Lincoln Laboratory, using to 1-meter telescopes. Since its 1998 launch, It has discovered over 140,000 asteroids, accounting for nearly half of all known discoveries, though much of its work was succeeded by the Catalina Sky Survey after 2005. Catalina Sky Survey, based at Stewart Observatory in Arizona, focused on detecting near-Earth objects in EOS. With 3 telescopes, it has annually discovered more NAS than LINAS since 2005. 3. PON-STARS Panoramic Survey Telescope and Rapid Response System, operated at Haleakala Observatory in Hawaii, using telescopes equipped with the largest digital cameras ever built, capable of 1.4 billion pixel images. It generates the world's largest astronomical datasets. Oumuamua, the 4th small celestial body discovered by the PAN-STARRS telescope, relates to asteroid impact early warning systems. Funded by NASA and developed, operated by the University of Hawaii, this program currently has 7 telescopes globally. These telescopes scan the sky for times every night to detect dangers days or months in advance and issue alerts, buying humanity more response time. However, since it officially launched in 2017, had it emerged a few years earlier, the 2013 Chelyabinsk impact might have caused fewer injuries. Even a few hours of advance warning to move away from windows could have mitigated harm. Thus, humanity's current asteroid monitoring is effective, but while smaller asteroids allow for evacuation, larger ones require technological or forceful solutions. Currently, methods exist to deflect asteroids: kinetic impactors, gravity tractors, laser ablation, and nuclear explosions. Only the first has been practically tested, launching a probe to collide with the asteroid and alter its orbit. NASA's Double Asteroid Redirection Test DART demonstrated this, targeting the Didymos Binary Asteroid System Primary Didymos, 780 meters diameter. Moonlit Dimorphos, 160 meters diameter, a spacecraft launched on November 24, 2021. Successfully impacted Dimorphos 11 million kilometers from Earth on September 26, 2022, shortening its orbital period by 32 minutes. China plans a similar experiment this year, targeting the 30 meters diameter near-Earth asteroid 2019 Vol5 with a probe to test orbit-altering efficacy. The second method, gravity tractors, is less destructive. A spacecraft approaches the asteroid and uses its gravitational pull to gradually nudge the asteroid into a safe orbit. However, this requires advanced technology and decades of time, and may fail for larger asteroids. Third, laser ablation involves firing lasers from a nearby spacecraft to vaporize surface materials, generating tiny thrust from expelled gases. This works best on loosely structured asteroids, with limited effectiveness on solid ones. Finally, nuclear explosions, intuitively appealing, remain untested. Key barriers include the 1967 UN Outer Space Treaty banning nuclear deployments in space, and the risk that fragments from blasting large asteroids could remain threatening uncontrollable hazards. Nuclear use would be a last resort for dinosaur-killing class asteroids greater than 10 kilometers diameter, with no alternatives if even that fails, but such impacts are non-threatening within the next century. Smaller asteroids are manageable, and global space agencies are advancing Earth's defense systems. Future technologies will only improve our safeguards. So, dismiss fear-mongering news. Humanity's asteroid defense is robust, and panic is unwarranted.